All right, so we're going to talk about exponential functions today.
Be quiet, Ethan.
All right, so an exponential function looks like f of x equals a to the x. A has to be greater than 0, and it also cannot equal 1. The domain of an exponential function is going to be negative infinity to infinity. All right, so we're going to do some calculator work today, and you're going to have to know where to put parentheses and how to enter this stuff. So everything on these next quizzes is with a graphing calculator. All right, so be real careful with your parentheses. All right, so I'm going to give you some problems, and you're just going to put them in the calculator and make sure that you can evaluate it correctly. Okay, so let's say I have 1.005 to the 400 power. I would like you to calculate it, yeah. Try to put it in the calculator, and you should get 7.352. Everybody able to get that? Okay. We're going to try a couple more. So 3 to the 2 pi, and for C, let's do 5 to the power of root 3 plus pi. So try to enter all of those. Did you get 995.042 and 53.976? You'll notice that I'm rounding to the thousandth. Everything that we do in here is going to be rounded to the thousandth, unless it doesn't make sense to round to the thousandth. And then we'll have to think about that. We'll talk about that in a little bit. Everybody okay with the calculations using your calculator?
Hold on.
You guys okay? Yeah, it's root 3 plus pi back there. Okay. So often, the irrational number e is used as a base of the exponential function. Well, let's say of an exponential function. E is referred to as the natural base. Okay, so like pi, E is just an irrational number, and E is approximately 2.718281, blah, 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 blah. Okay, so just understand that it does have a value. Yeah?
Okay.
So go ahead and put these in the calculator now. So let's say E squared and E to the 2/3. All right, try to evaluate those. Did you get 7.389 and 1.948? Okay, everybody good on those? Easy stuff so far, right? So some of the calculators are updated so that you don't. Others you might have to put parentheses around the 2/3 power. Okay, so it just kind of depends on your calculator. All right, let's take a look at a graph. Oh yes, sure, sorry. Let's take a look at a graph of an exponential. So we'll call this example 2. How about graph y equals 3 to the x? Can I move this now? Okay. So y equals 3 to the x. Before we put it in the calculator, let's just talk about it. What kind of values are you going to get when you plug in different types of numbers? So let's think about, let's first think about the y-intercept. What's the y-intercept of this? Yeah, isn't it 0, 1? Right? In order to find the y-intercept, you plug in 0 for x. Anything to the 0 power gives you a 1. So with any exponential function, you will have 0, 1 for a y-intercept, unless there's a translation, shifting it up or down, okay, or left or right. How about the types of answers? Can you get positive answers, an answer of 0? Can you get negative answers, depending on the x values that you plug in? Remember that the domain is negative infinity to infinity. What kind of answers can you get here? What kind of y values do we expect to see? Positive, right? Can you get a negative answer? Is there any number I can plug in for x that will give me a negative answer? No, because when I plug in a negative power, what happens to this?
Error.
Like if I see, no, not error. If I plug in a 3 to the negative 1, what do I get? 1/3. It just flips it, right? If I plug in a positive, like let's say 3 to the first power, don't I get 3? All right. So no matter what I plug in for x, I'm going to get a positive value. What happens here is we have a horizontal asymptote at y equals 0. That's because it's going to get really, 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 really close to 0, but it can never get to 0. No matter what I plug in here, I can't get an asymptote, or I mean I can't get an answer other than of 0. Okay? So now let's take a look at the graph, and you can put it in your calculator if you want, but we're just going to do this by hand, just based on what we've talked about. So I know that there's a horizontal asymptote at y equals 0. Okay. I also know that it has a y-intercept of 0, 1. And then I just really found 2 points, didn't I? I found 1, 3, and negative 1, 1/3. So exponential functions look like this, where they're approaching 0, but they don't touch it. All right, they get really close, but they don't touch. And depending on your base here is really dependent on the steepness of your graph. Okay, so how steep is your graph? So if I was to say graph y equals 5 to the x, how would that look different? So it would be steeper, right? Wouldn't it still have a y-intercept of 0, 1? Right? Now when you plug in 1, you're going to get 5. So it's going to be up here. When you plug in negative 1, you're going to get a 1/5. So it just rises a lot quicker and steeper. So that's the difference there. Okay? Do you remember that from last year? Yes, hopefully?
Yes.
Okay, so let's talk about transformations then. Alright, so when you have an exponential function, we're going to have a to the x, but you could also have some transformations going on here. So let's add in this h and k. So when we talk about transformations, generally we talk about p, r, s, and t. However, now we won't talk about s. S is going to come from the base. So it's based on the base of the exponential function. Okay, like we saw above, when it was a 3, it rose less quick than when it was a 5, right? When it was a 5, it was steep and it rose quicker. Okay, so that's where you're going to think about your stretch and your shrink value. Okay? The parent function is just f of x equals a to the x. All right? And then how do you know if there's a reflection? We talked about this before. How do you know when there's a reflection? There's a negative, right? So if the negative is with a, then that means it's like not locked inside, right? You could move it over with the y value. And when you do move it with the y value, what does it reflect over? reflects over the x-axis, right? If it's with the y, it reflects over the x. If it's with the x value, where does it reflect? Very good. Reflects over the y-axis. Okay? And then T stands for translation, and that's, remember, you're shifting. So H is going to shift it left or right. Remember, plus is left and minus is right. And then K is going to shift it up or down. Up is plus and down is minus. Alright, so this should be a review. And let's look at a couple examples of those. They're less formal than the ones that we originally did. Can I move this? Okay, so this is example 3, and we're just going to describe the transformation. Okay, so let's say we started with y equals 3 to the x plus 1 plus 4. Everybody agree that the parent function is y equals 3 to the x? So you're going to kind of ignore the 3, right, and focus on that 1 and 4. So what is this doing? Isn't it moving left 1 and up 4 units? Everybody agree with that? What if you had y equals 3 to the negative x plus 2? Think about that one for a second. There's a reflection, right? Is it over the x or over the y? Good. So it reflects over the y-axis. How about that shift? Is it left or right? It's left because it's plus. Hannah, why not? Exactly. You have to factor this negative out. It's affecting both of those pieces there in the exponent. Remember that trick we did on the quiz and the test? Yeah, a lot of you got that one wrong. So hopefully this time we're going to get it right, right? So if it's locked inside, that negative's locked inside, it's affecting both of those pieces. You have to factor the negative out before you describe the translation. So that means that this is shifting right 2 units. Okay? Moving on. We're going to talk about some applications of this stuff. So you guys always ask, when do we see this in real life? Well, here it is. So, yeah, finally, right? This one section. It's the only time you'll see it. I'm kidding. Sort of.
Please be kidding.
So compound interest, we have A equals P times 1 plus R over N to the N times T. You remember this formula? This is it. This is it.
All the marbles.
Okay, let's talk about all these pieces. A, P, R, N, and T. Okay, so A stands for the amount of money after a certain number of time. P is your principal amount. It can also be thought of like as your initial investment. R is your interest rate. But it has to be in decimal form. N N is the number of times it's compounded yearly. And then T is time in years. Okay, so this is when it's compounded a certain number of times during the year. There is also compound continuous interest. And this one you probably remember better as PERT. Remember that? A, P, R, and T, they all stand for the same things that they did above. Okay, remember that E is that exponential base of 2.71 ... Okay, so that's like a number, so E's not changing. Ready to do an example?
No.
Of course you are. So, example 4. Let's say we have $5,000 invested at 5.5%, and we're going to compound it, and we're going to talk about a few different things here. Before we do this problem, we need to go back and talk about some wording, though. So let's take a look at this again. When you think about this, specifically compound interest formula, if I say it's compounded annually, how many times is that in a year?
4.
Okay, let's try it again. If I say it's compounded annually, that is 1. You might want to write that down.
Hey, you asked
If
that
I say it's compounded semi-annually or biannually, how many times is that?
Dose.
2. If I say quarterly, how many times?
4.
4. If I say monthly, 12. If I say daily, 365. Okay? So if you don't know those terms, you might want to make notes of those terms, because these terms will come up within these story problems. Yes, Ethan?
Will there be a weekly one?
No. I guess if there was a weekly one, it would be 52.
I don't even.
How much hourly?
60 times 365. No, that's wrong. That's so wrong. 24 times 365. Would it be nice if we had 60 hours in a day? Oh, I could get so much done. No, that's like -3 at least.
That's like -5.
Now let's go back to our problem here. So we have $5,000 to invest. It's going to be invested at a 5.5% rate. But we're going to run 2 scenarios. We're going to compound it quarterly. I wish I could spell that. For 3 years. And we're also going to compound it continuously for 3 years. So that means we have to use both of those formulas. Okay, so compounded quarterly means what? Which one do we use? PERT or the other one? The other one. So I'm going to use A equals P times 1 plus R over N to the NT. And let's think about what all those pieces represent. A is the amount of money we're going to have after the 3 years, isn't it? So that's what we're looking for. We're looking for A. P is, which was, so 5,000. 1 plus R. Now R has to be in decimal form. The rate was 5.5. What is that in decimal form? 0.055. You move the decimal to the left 2 places in order to convert from a percent to a decimal. Divided by N. Now N is 4 because it's quarterly. And then that's raised to the power of 4 times 3 because 3 years are passing. You can put this in your calculator as is. if you put parentheses around this piece, and you could just multiply 4 times 3 to put 12 in there, or put parentheses around this. Okay, so try that now. Try to enter this into the calculator and make sure we can get the correct amount of money. And then think about what the appropriate place to round to would be. Did you get $5,890.34?
That's not really the best.
So now it doesn't make any sense to not round to the 100th here, right? Like we would never round to the 1,000th place. You would always round to the 100th because that's how we talk about money. All right, how about continuously? Which one are we going to put our information into? Hert. So A equals P times E to the RT. So A is still what I'm looking for. $5,000 is what I initially invested. E is just a number. R is still 0.055 and T is 3. Enter that into the calculator and see what you get. Did you get $5,896.97? Okay. So is everybody comfortable with plugging in the information and then putting it into the calculator and evaluating? All right, one more formula. So we're switching gears here. Let's talk some science. Let's talk about radioactive decay. So radioactive decay looks like Q equals C times 1/2 to the T divided by the half-life. Okay, we're going to talk about what the pieces represent. So Q is the amount of material left over. Okay, Q is the initial amount. That's what I meant, C. Thank you. C is the initial amount of material. T is time in years. And the half-life is the half-life. I don't know why it's not an H, but
So that's like just 2.
no, it's more like probably like 2,000, but yeah. It's just, it'll be a number. They'll tell you the half-life is this amount of years and you plug that number in. Yeah, it's just what it says it is. Okay, so now, I don't know if you noticed, but so far we have 3 formulas for this chapter. The good news for you is that I will give you all of the formulas on the quizzes and the test.
Sweet. This is like.
And you're probably thinking, who is this woman sitting in front of us today? It's me.
There's a catch there.
There's no catch.
There's a catch.
Always a catch.
Let's wait for it.
It could be a small catch.
The catch is every problem.
It's quite small though. So remember those words we were talking about, like the quarterly and the semi-annually and things like that? That is really the only way for me to make this slightly more difficult, right? Is to try to kind of trick you on the wording or the units. So you have to read carefully. So you have to be very aware of what that means in terms of how many times it's compounded, or the fact that this has to be in years. Maybe I would tell you, you know, after 48 months, this time has passed. You would never plug in 48 though, right? Like you'd have to convert it. So that's really the only way to kind of upgrade this. So keep that in mind as you're reading through these story problems. All of these next quizzes and the tests for this chapter are very heavy in story problems, okay? But most of the information is just going to be given to you. So you have to be comfortable with your calculator, and you have to be comfortable really interpreting what the meaning of those, you know, some of these words and problems are asking you to find. Okay? Sound good?